Hi mathematicians, it's Dr. J again, and this is the third in our series of how to find the equation from the graph. This time we're dealing with growth curves or exponential curves. Those are those ones that go along and then go faster and faster and scoot off into infinity. So if you can see the graph and want to know the equation, how would you work it out? That's what we're going to deal with. I'll give you 3 examples with this one, starting with the easier, moving on to the harder, and then I'll give you a little bit of insight into the formula that I'm using and finish with a couple of practice questions. So hope it helps. Let's get into it. Okay, here's one of our first exponential graphs we're going to work out the equation for. It's exponential because I can see it's got that nice scooting off towards infinity type shape. That tells me I'm dealing with a growth curve or an exponential curve. On the right here, we've got the formula that I'm going to use, the y equals base to the power of x plus asymptote. And we're going to see what that means by looking at this example. Okay, like always, I want to work out what my letters should be first of all. And so first letter up top here is a D, and second letter is a C down here. So over here, instead of y, I'm going to be using D equals, I'm going to have the base to the power of C. So I'll write C up high, and then I'm going to add the asymptote. Okay. Now, with these types of graphs, the first thing you actually have to find is the asymptote. After you've found the asymptote, you can find everything else. Now, the asymptote is that horizontal line that it gets closer and closer and closer to. Now, sometimes it gets closer and closer to it on the left, and sometimes it gets closer and closer on the right. It doesn't really matter which at the moment. But you try and draw in on the graph where it's that asymptote is. Now, on here, I can see on the left, it's getting very, very close to that point there. So if I just draw a dotted line like so, this line going all the way along, on the left, it gets closer and closer and closer to that, and it never actually goes below that, and it never even touches that, but it gets close to that. That is your asymptote. And where does it cross? It crosses at -2. That's the -2 line. So my asymptote is -2 because it's on the -2 horizontal line, or D equals -2 line. Okay, once that's done, I can now find my base. You'll notice, first of all, that on the d-axis that the crosses here at -1, which is 1 above the asymptote. From the asymptote up to that point is 1. That should always happen when you've got a growth curve, unless they're doing a really tricky question, which we're not going to deal with. The growth curve should always cross at 1 above the asymptote. What you then want to do is move a little bit further along, 1 along, and see how far you are now above the asymptote. And I'm going to do that in a different color actually. I'll do it in red just so it stands out. If I move 1 along in this direction over here, I end up at this point. That's moving 1 to the right. And now you'll see that the distance above the asymptote is actually 2. And that means that the base is 2. Okay, so when you move over 1 so that you get a larger distance from the asymptote, work out what that distance is, that's your base. So I can immediately fill in the base of 2 here. And that is actually the answer. We're already done. 2 to the power of c minus 2 is my equation. It might be a good idea, however, just to check that it is the equation by trying another number. And a good one to try would be, for example, this point up here. See if it works for this point. This would be just a quick check. That point, by the way, is the point 3, 6. So let's see if that actually works. What happens if I go 2 to the power of the c is the 3. So what if I go 2 to the power of 3 minus 2? Do it on a calculator, you actually get 6. And that's perfect, that works. When you use c equals 3, you get d equals 6. I know I've got the right equation, okay? But I'll just rub that out so we don't need it anymore. Okay, we're into our second exponential example. This one, clearly an exponential again because it's getting that rapid acceleration. This time though, it's accelerating downwards rather than upwards. We're going to see that reflected in a different answer. But it's definitely a growth curve or an exponential curve because we've got that rapid movement and also getting close to a horizontal line on the other side. Right, so first step, what are our letters? Let's work them out. We've got a y up here, we've got a q down here, so we're going to go y equals, it'll be the base to the power of q, and then plus some asymptote. Okay, what is my asymptote? Remember, it's that horizontal line that it gets closer and closer and closer to. It gets closer and closer and closer to this line here, which is the 5. So it's a positive 5 on my asymptote. That's that line. Now we need to work out the base. Okay, so remember that I said on that vertical axis where it crosses should be a distance of 1 away from that asymptote. And that's what we've got here. That's a distance of 1. So that's good. This time though it's going down rather than up, but we'll worry about that later. Now in red I'm going to move further along, just further along by 1. So along here, and where am I, if I move just over by 1, where am I on the curve? I'm all the way down at here, much lower. Okay, so how far am I away from the asymptote now? How far away is this distance? Well, it's actually 4. I've dropped from 5 to 1, so it's a distance of 4. That tells me that my base is 4. It's 4 to the power of q. Okay, so that's good. We've got one thing to deal with though. If I tested this out, I would find that this equation doesn't work for this graph because the equation I've currently got would move along and then it would go upwards because we would be adding 4 to the power of q and that would get bigger and bigger and bigger. I actually want it to go downwards. So when you see something that goes like that, scooting down, it tells you that you're going to need a minus in front of it, just because that's going to make it go lower and lower and lower and lower. And so that's how this one's slightly trickier than the first example. Because it's going down faster and faster, I'm going to need a minus in front of that base. If you test that out by a random point, you will see that it works, but that's basically it. Okay, we're into our third and final example of another growth curve. Again, we've got a horizontal line that it's getting closer and closer to. We've got sort of fast acceleration on the other side, accelerating on the left this time and downwards. All right, so how are we going to work out that equation? First step, let's get our letters in. We've got a y up here, we've got an a down here. So we're going to deal with y equals the base to the power of a plus some asymptote. Okay, what is our asymptote? That's this horizontal line here, which is at 1, so it's a plus 1 for my asymptote. Notice, as I said in the other two examples, the gap between the asymptote and our curve is 1. And this time, as before, we're going to move 1 across and notice what happens to the distance to the asymptote. If I move 1 to the right like I did in the other examples, if I show it in red, if I move 1 to the right here, you'll notice that I actually get a smaller distance than before. It's about a half. Now, you could actually use that in another way than I'm going to, but what I like to do is always move in the direction where the gap to the asymptote gets bigger. So instead of moving 1 to the right, I'm going to move 1 to the left, 1 this way, which takes me down to this point. And I find that this is going to be easier to work with. That I look at that gap to the asymptote, and that's a gap of 2. And that tells me, therefore, that I'm going to use a base of 2. So just to say that again, I'm going to rub out this one over here on the right. I don't like to use that. I like to use the one that is actually further from the asymptote. And so sometimes that means I move to the left rather than the right. But I always move by 1. 1 to the left or 1 to the right. Okay, now we've got some issues to deal with. unlike the first example we have, which was going up like that, we are actually going underneath the curve. We saw that in the previous example, in example number 2, that we were also beneath. That tells me that I'm going to be putting a minus in front here. That minus in front there, minus in front of the base, tells you that everything is below the asymptote. So, okay, this is the below asymptote minus. If everything's above the asymptote, you don't put that minus in, it's a positive. But if everything's below the asymptote, as this one is, if everything's under, you're going to have a minus there. Now the other place where I could put a minus in is up here with the power, and we haven't dealt with one of those yet. The situation where you put a minus there is if it accelerates on the left. Now we've got this acceleration on the left here. That's where it's going further and further from the asymptote. In the typical basic growth curve, the one that goes like this, it accelerates to the right. But if you're accelerating to the left, that means you also need to put a minus in front of that power. Okay, so that there is the accelerate to the left negative. If it's accelerating to the right, if it's going like that or it's going like that, you don't need that minus. It's only if it's going accelerating to the left of the graph that you put that minus in. So this is clearly our trickiest example because it's got a minus because everything's below the asymptote, and that's that below the asymptote minus. And it's got another minus in the power because it's accelerating to the left, not to the right. So quite a lot to remember there, definitely our trickiest example, but if you can understand that, my goodness, you're doing well. Congratulations. Okay, so here's a summary of the sort of formula I used to work out the equations for those exponential graphs, with a bit of detail underneath, explaining what I mean by asymptote and what I mean by base and how you'd work those out. The trickiest part, of course, is when do you put the plus in or the minus in, and so there's some detail about that at the bottom. Probably a good idea to take a screenshot of this so you can review it later. Thanks for watching. That's the end of that video and how to find the equation from the graph. I'm going to finish with 2 questions that you can try and answer. If you think you know what the answers are, put them in the comments and I'll try and give you some feedback on those in the comments. So thanks for watching. Here we go.